Hello YouTube. I've been messing around with power supplies recently, and I was trying to fix one which was an XFX 650 watt, but the entire mains power stage of the power supply was completely destroyed. So basically I've cut the board in half along the isolation gap, which removes all of the main side, and desoldered the main transformer. There's two transformers on here. This one was for standby voltage, and this one is the main power transformer for your 12 volt, 5 volt, 3.3 volt. And so basically my idea is to make a PC power supply that is direct 12 volt input with switching capability to get it down to the lower voltages. So far I've just been messing around in the audible hearing range with switch mode using the Arduino and a little bit of code, and basically I have an IGBT and a fast switching transistor and going into the Arduino. So when I connect this to the battery, you should be able to hear an audible frequency, and that fan should start spinning and there should be a voltage displayed on there. So you can see the fan spinning. It's making a really annoying high-pitched noise, and so far I've got 2.6 volts, but I'm going to be tweaking that until I can get a higher voltage of 12 volt, because this is on the 12 volt rail of the power supply. The other side of the PCB, which I cut off, is here. Now that used to have that heatsink there attached to it with various semiconductors. There were two MOSFETs there and two MOSFETs there with a diode in the middle. The two MOSFETs on the end had blown, and one of the far right, and I'd already replaced them once and checked the rest of the circuit, and it just blew them again. So I thought, sod it, I'm going to do this, and I've always wanted to make one of these. So this is the main power supply area where the mains would have came in. That chip there is a switch mode controller for the standby voltage transformer there, and I believe that one there controlled the main power transformer. And obviously there were some optocouplers up there that fed back through the winding to that controller, so that it could adjust the output accordingly. And as you can see, there's a big Nippon Chemicon 400 volt 470 microfarad capacitor on there, and bridge rectifier, and then various filtering stages. The fuse I'd temporarily bridged with just a piece of wire, because I was using it on a ballast anyway, to see what was wrong, and couldn't find anything, so that's why that is now disassembled. Anyway, thanks for checking out my video, and I'll post more when I've made further progress with this particular project. Thanks for watching.